Thank you for having me. I'm Cristiano. I'm a software engineer at Facebook. So before working on Reason, I spent several years working on static analysis on a tool called Infer. Static analysis is about finding bugs in your programs without running them, just by analyzing the source code. And one of the challenges there is scalability. The reason why scalability is so hard has to do with the so-called problem of state explosion. If you want to analyze your program and try to enumerate all the possible states, the analysis will never terminate. So with Infer, what we did was to analyze each function in isolation and only focus on the relevant part of the state. So by focusing on the local state, or as local as possible, was the key ingredient to scalability. So today, I will talk about ReasonReact from the point of view of local state. So first, what is Reason? Reason is a statically typed programming language. The type system comes from OCaml, which has actually been around for more than 20 years and was developed just 1 hour away from here. What the type system offers is a powerful form of type inference. And what this means in practice is that even though you use a type language, you need to write very few annotations because most of them can be inferred. So in terms of design goals of the language, a very important goal was to make it familiar for JavaScript developers. So it went through several iterations of the syntax to make it as close to JavaScript as possible. And another important aspect is that it compiles to readable code. So in your team, not everybody needs to learn a new language if you adopt it gradually. So you can check in the compilation artifacts and anybody can look at them. So it's a very smooth transition process. Another property is that you have fast builds thanks to the Buckle-script compiler. In particular, incremental builds are pretty much instantaneous. And the final point in the design space is that there is a lot of focus on FFI for interaction with JavaScript. So at the interface, you can annotate with types. And so you can use your libraries in a safe way. So what does it look like? This is a record type state, which has 2 counters and a toggle. The counters are integers, and the toggle is a Boolean. To create a new instance of this record, you just specify with the syntax that you're used to. And to update the object, there is the spread syntax. So far, everything should be completely familiar. Now, when you define a function, here I have a screenshot of VS Code with code lenses that show you the infer type. So the plus function is inferred automatically to have type integer to integer and returns an integer, just because plus is an operation on integers. So you see in this case, you get essentially the types for free. In addition to this form of functions, there is another form that requires specifying labeled arguments. So if you look at foo with labels, this twiddle text, that means that the first argument is labeled, it's called text, and it's also optional. By providing a default value, the string number, you specify that the argument is optional. So there are 2 ways of calling this function, foo with labels. You can either pass it a number, which corresponds to the second argument v, and so the default string number is used. Or you can explicitly pass text equals val, and so you override the default value with the string val, and so the new value is used. So after this, let's switch to ReasonReact. ReasonReact is an interface for React written in Reason. It allows you to write React components in Reason, and it has itself a few design principles. The first one is that it is type safe. So what that means, you're not going to get type errors at runtime. Another design principle is to make the side effects explicit. So from the introduction of React 16, you have this situation in which your life cycles could be interrupted or executed more than once sometimes. And so in this interface, we made sure that every form of side effect is explicit, so you know when it is safe and when it isn't to perform side effects. And again, there is a focus on interoperability. So there is a way to write a reason component that uses a JavaScript component and vice versa. So what this means is that in your team, you can, if you're interested in try, you can just convert a single component and see how it goes and integrates with the rest of the system. That's the only change that you need to make. So let me dig a little bit deeper into what I mean by type safe. First of all, the state, if it's a stateful component, is always initialized. So you're not able to forget to initialize your state. And perhaps more importantly, there is no way at all to access your state directly. The only way to access the state is when the life cycles give it to you. Right? And so when you update the state, you also have a guarantee that the type is maintained. So you're not able to use a component which thinks of operating on one type, instead operates on another one. And so we actually went to the full length of verifying that the design is type safe. So my first contribution actually in this area was to break type safety of ReasonReact. And the way we figured out was that we implemented a small reconciler entirely in Reason without bypassing the type system at all. So by using the same interface, you know that there cannot be any type errors. And we couldn't type like the change that I've made, so we figured out what the problem was. So this is how a component in ReasonReact looks like. There are two things. There is a component, and then there is a make function. The component, you specify which kind of component you want. It could be stateful or stateless. And the make function is used to create instances of the component. In this case, going back to the labeled arguments, props are specified just by labeled arguments of this function. So in this case, you have prop 1 and prop 2, and the way you specify life cycles is by spreading the component object with its mount, render, or whatever you need. So this is the simplest possible component you can write. It's a stateless component. The only thing it does, it takes a prop called name, and then it shows a button with that name. Now notice that the JSX syntax is supported for button, but also notice that the component is enclosed in a module. Think about the module just as a collection of values. In this case, the module is called name button, and by calling it that way, we can then use the JSX syntax below, and the way you pass it arguments is in the usual way, name equals an. Okay, with this out of the way, let's talk about global state. What is global state? The best example is the DOM. So you have this huge tree. Everybody can look at any value. Anybody can modify any value. And I guess we all agree that it's not so easy to program directly, and that's the reason why frameworks such as React have been created. So now I want to go through illustrate global example by the simplest possible example in ReasonReact. So we're going to have a small app with 2 counters and a toggle. So you press plus to increment it, minus to decrement it, and toggle to change the value. We're going to use a global store, which contains the current value, which is 2 integers and 1 bool. And every component will have access to the same global store. So let's look at an implementation of the first counter. So counter 1. It takes 2 props. So it wants to know what the current state is, which is the global state. And it takes also an update function. So it doesn't matter how you have access to the state and to the update function. It could be that you have registered in some way. But let's say that they're passed by props just for illustration. So then you proceed to create the two buttons and to show the current value. Now, when a button gets updated, here, I specified that I'm going to update exactly the field called count1. And the same thing for decrementing. So now, when you put everything together, so imagine you create a few counters. Each one takes the current state and update function. Only that what I did, for some reason, I just repeated the counter2 twice. Okay. And then I see what happens. I click on the first counter. Okay. I click on the second counter. And what happens here is that both the second and the third counter get incremented when I click on them. Also, every time I click on anything, every component gets re-rendered. So the reason for that is that the state is global for everything, and if you work in a naive way, there is no way to know what should be rendered, what shouldn't. You need to do extra work to specify that. And also, it's kind of an easy mistake to make is to use the same component like this one twice, so that the same field count2 is used by both instances of that component. So what you have is that it's easy to compose components, but it's not easy to make sure that they don't interfere with one another. Or at the very least, it's an easy mistake to make. So next, I will go through the same example, but from the point of view of local state. To do that, we're going to introduce a reducer component, which is a component with state. It has a bunch of ingredients. It has a state and a set of actions that operate on that state. It has the initial state, and then you need to specify a reducer callback. The reducer callback specifies how each action operates on state. And finally, you need to have a way to send actions to the component. So now, the local version of the counter, I need to specify this state is just an integer. There are two actions, increment and decrement. And then I have, for the reducer function, I can do pattern match on the actions. So if it's an increment, I update the state with state +1. If it's a decrement, I update it with state -1. So this form of pattern matching is quite interesting, because if you add the third action later and your pattern matching is not exhaustive, the compiler will warn you that you forgot one case. Or if there are cases which overlap, it will warn you that they overlap. So it's going to help you to maintain your code later on. And so to put everything together, the only thing I need to do is that when there is a click, I just need to send the appropriate action, either increment or decrement. So what does the example look like now? Instead of having counter1, counter2, counter3, I just have 3 times local counter, because each one has its own state inside. And then when I interact with it, what happens is what you would expect, right? So there is no interference between them. In addition, only the component that you touch gets re-rendered. And this just happens by default. We didn't have to do any work to do that. Right, so let's look at animation now. I work with Cheng Lu, who introduced React Motion here a few years back. And so we had this kind of sequence of interactions in which he would show me an example. He would say, can you do that? And say, here is the image gallery. And then I would go ahead, implement it, and I show it to him. And then he asked me, how did you do it? And then the way I did it was a little bit different from the way he did it. So he was taking all the images, drawing them, and then just scrolling the window. While what I was doing, I was just taking 2 images and then scrolling between them. Okay, one difference. The next thing that he asked me about was chat ads. Right. So they follow, and then he asked me again, how did you implement it? And there was again a difference. So the way he had implemented it, he had kind of a list object. It was controlling the entire animation. And the way I had implemented it was that each head was controlled in a separate way. The only thing it knew was how to move to the destination point and how to tell the next head where to go. So I thought that was quite interesting. So I thought, I mean, what's this difference? So basically what I was trying to do was to make these animations as local and composable as possible. So I started asking myself, like, where is state in animations? What does it mean for state in animation? So if you think about the animation, what happens when you start the animation and when you stop it, state is what determines what happens in the middle. So if you have a video, time is your state. If you know the time, you know what is the current frame. Or if you have a few objects going around, the state is the position of the objects, velocity, their properties, right? And so when I learned about springs, I was very interested. I started to think about state inside springs. Like you can take a spring, you can pull it, and then let it go. It will oscillate for a while and then get to a rest position. And so its state is basically inside the spring. And what does it look like? So it has a few static properties. So you have the resting position, you have the stiffness, which tells you how hard it is to press it, damping, which determines how quickly it stops oscillating. But then there is also some local state, which at any given point, it tells you what is the current value of the string, what is the velocity, and what is the destination. And an interesting property of springs is that they are inherently composable. So you can take springs, put them together, at least intuitively, connect them. Each one will have its own state. They will interact, but they will not interfere with one another. Right? Okay, so next I'm going to show how to give the simplest possible example of springs in ReasonReact. So we're going to have a spring component. The only thing it will do, it will oscillate the target value between 1 and 0 and show you how the value changes, right? So you click, goes from 1 to 0, and the value changes. So to do that, we have a state which has 3 things in it. There's going to be an underlying animation object, which will be responsible for sending all these values at any point. And then we will have the current value that the React component knows about, and then the target value, which is either 0 or 1. And then there are exactly 2 actions in this example. There is a button, so there is a click. And then there is the value action, which every time the current value changes, is responsible for updating the local state. So in this case, we're going to take as a prop a render value, just because we want to be a little bit flexible about how to show what the current value is. And then initialize the state by creating the animation. And on mount, we will specify the properties of this animation. So in this case, we specify what happens every time the value changes. Every time the value changes, we're going to send the action to the component so that the component state gets updated accordingly. And then we specify the final value. Now, what the reducer does is, let's look at the click. In the case of the click action, there are 2 things that happen. So one, I switch between 0 and 1. And then I have, referring to what I was talking about before, an update with side effects. So there are 2 things that happen here. There is a state update that is not allowed to perform side effects. The only thing it does is to update the state in the future with a new target. And separately, there is the side effect. What the side effect does is it interacts with the imperative animation object. And so it will change the final value. So what happens in async mode? So even if the state update gets interrupted, it doesn't matter. Eventually, it will be set to the current value. And only when the state change is committed, then we will operate imperatively on the animation object. Right? So now we have seen the simplest example of Spring, and next I want to start to talk about composition. How do you compose two things? What I will do, I will take a text input component and animate it. I will not show the text input component, I will just show the state and action. A nice thing in this case is that just by expressing the type of the state and the action, you already get a good feeling of what the component is going to look like. At some point, you get into the habit of just looking at that first, as if it was the interface to your component, to understand a little bit of what will happen in it. So in this case, in a text input, you only have a state, which is the current text, and then the action to update the text when you type in the text box. And then we're going to animate it. So the way we will animate this is by changing just one thing. So again, we will use a Spring, and the only thing that we will change is the render function. While before the render function was showing the number directly, now we're going to show the text input instead, and we will use that number to shrink the text. And that's pretty much all there is to it. So we can click, we can edit the text box, the state is preserved, and then we can animate it again. So what you're seeing here is that there are two components. There is the text box. Its state is the text. That's all what it knows about. And then there is the Spring. Its state is this value between 0 and 1, and that's everything it knows about. But then it's possible to compose them in the way that they interact without interfering with one another. And the only thing that we did to compose them was just to use simple function composition. We just changed the render value function. So, back to the examples. So now I'm going to start showing an example of how to take building blocks and compose them together. So we have an image gallery, and oh yeah, just out of curiosity. So this image gallery, internally, it has a value. If the value is 0, it means the first image. If it's 1, it means the second image. 2.5, it means halfway between the second and the third image. So once you set up things in this way, the only thing you need to do when you click is to change the Spring to go +1. That's the only thing you need to do. So now we have seen the chat heads, and well, we can also compose things. For fun, you can still click on them. And here I have a little playground, so we can add a button that animates in, another one, so you can click on them. Then you also have a way to remotely trigger these actions. So you click all the buttons at once, or you can remove an item, or these buttons know how to close. So let's close all the buttons at once. But I can save one before it's finished. I can add an image. I can reverse things. Also, you can just start and see, okay, I'm going to do all the random actions, right? Why not? And so now, like, it's nice to compose things, and then as the ultimate test, it's a little bit crazy, but why not? Let's add an entire copy of the application. And why not 2? And then let's start some random animation in one, at the same time a random animation in the other, and while they go, we can reverse them. We can remove an item, which disappears slowly, or we can animate away also the second item. So, to wrap up, I presented ReasonReact, a little bit of introduction to how it works. I've spoken about local state, And I've shown some examples about component composition. And basically, I would argue that local state is helpful in making it easier to compose components. And if you're interested in the examples, they're all available over there. Thank you very much.